Okay, so guys, welcome back. So I believe you guys you're doing good, and very okay. I believe just everything's fine, and then your exam is so far so good. Okay, guys. So today we're just gonna discuss a famous and very important subject, so which is chemical engineering, and today we're just gonna talk about material balance. So what I wrote on this paper is just for you guys to have some few line, because when I'm gonna start solving questions, you guys you have to know what I'm writing. So we're gonna discuss about material balance problem, how we can approach them. We know when we say about mass, the material balance is just something like a mass in is always equal to mass out. No matter how things you have, even you have chemical reaction, even you have anything and so on, it means your mass in is equal to your mass out. That's the first step. Now, guys, how to solve material balance? That's why I wrote A, B, C. Those they're just gonna help you guys so that you can simplify your things. The first things is, as engineers, you have to read the problem carefully and to be able to know what they're asking for. If you read the question carefully and then you are able to identify what they ask for, from there you can solve. That's why I wrote here that's gonna be like your keyword in terms of phases. So, and you have also to be careful when you are you are assuming something. So assuming something is very important in engineers. You can't just assume any number because you want or you feel, but you have to make sure when you assume and carefully when you are reading your instruction. So the second one is to draw a picture to build the known and the unknown. Why I'm saying this? The reason why I'm saying to build the known and the unknown, this is the things is gonna help you if the question says find the degree of freedom. The degree of freedom is just basically about the known and the unknown. So by definition, if they ask you what is the degree of freedom, you can just degree of freedom. It means just the unknown one. Let me just put there unknown minus none. So that is by definition of what? Of degree of freedom. So then now guys, after you draw, you label your picture, you have to understand something very important. This M, it means mass, you know. This N, it means moles. This X is mass fraction. And then this Y, it just means molar fraction. And then solve for easy unknown ahead of the time of two component system. So guys, what does it mean there? When you have been given a questions or any chemical reaction, make sure to solve where you find few unknown. So let's say you have a question, you have 3 unknown and then 2, just go for where it's 2 because the small one, then you're gonna solve the question. For instance, what I mean, let's just make it example. Let's say you have x plus y plus z equal to 1. You see, to solve this question is a big challenge because you don't know x, you don't know y, you don't have things. But let's say you have x equal to 3 and then minus, let's say y. This is gonna be easier to solve because you have only 2 unknown. You can say, okay, if y equal to 0 and then you solve for x. But if you say x equal to 0, you see you're gonna left again with 2 unknown. So it's very important. So, and then the C1, it starts with the mass balance. So it means every single time when they give you a things like a material balance, you have to start with mass balance. And what is mass balance? Is mass balance in is equal to mass balance, mass out. I'm sorry, guys. So mass in is equal to mass out. And then after that, you have to do what they call the mass balance for every component. So you can be given many components like A, B, C, and then from there you have to do to be able to solve the questions. And then from there you have to do the mass balance independent. So it means each one, you can't put A and B in the same component balance. No. So if you do for A, you only do for A. If it's for B, you only do for B. Okay guys, today we're gonna solve a lot of questions. Maybe before we start, let's just see how we can do this. This is not you guys, you're gonna solve this by yourself, because me, I'm gonna solve 10 questions. So the video today is gonna be long, so probably 1 hour. So you guys, please, I'm gonna ask you to watch and then share with other students. So this kind of question is just to make sure to what we just said now. Let's see how we can approach these questions. For example, they say 2 stream enter a column. How many stream? 2 stream enter in the column. So it means you have to do, you make a box. This box, you can call it a column. This is a column box. It's a column box. And then they say 2 stream enter. So this is a first stream. And then there's the second stream. Guys, when they say enter, even you put in this way, you are fine. There is nothing wrong. Even you put it down, you are fine. As long as you want. Even you put in this side, you are fine. So this is mean. Like they say, in the stream 1, this is stream 1. So 30% of A. 30% of what? Of A. So it means this is a stream 1. I can call it its flow rate to become mass flow rate M1 because the stream 1. And then 30% of A. So I can say, okay, this is a percentage A, and then is what? Is 30%. 30% in times is 0.3. You see, guys? And then they say, and the rest is B. So the sum of percentage is 100%, or in terms of fraction is only 1. So we have already 0.3. To get 1, we need just to take 1 minus this. So we're going to have XB is what? Is 0.7. This is still the information of M1. And then the question says, in the stream 2, this is a stream 2 down. I can call as well M flow rate 2. And then they say, in this stream, guys, understand carefully, they say 40% of A. So we're going to have XA, which is 0.4. And the rest are C. Rest are what? Are C. So you're going to have XC. We take 1 minus this one. It's just 0.6. And then they say again, 2 streams exist the column. So 2 stream again. So they are leaving. In another way, they mean 2 stream are leaving the column. So it means and then they say they are leaving the stream. So, and then in that stream, they say what? They mean stream 3 is 100% of A. So you're going to have M3. And then they say X is already 1. So XA is 1. So in this stream, we don't have B or C because the sum is always 1. You see, guys? And then it says again, well, the stream 4, now guys, see, the stream 4 is 20% of B. So we're going to have M4 and then XB, which is 20%, or it means what? 0.2, okay? Now they say the rest is A and C. Guys, can you see? The rest is A and C. So what is the sum? We know already like the sum of these 3. It means we have XC there, and then we have also X what? XA. Now it starts with, let's just make it well. It starts with B, and then we have A. So this is A. And then we have what? We have also here, we have C. Now, how can you think? You can think mathematical. If you know this, it means to find this one, it's just going to have the sum of, I'm sorry guys, it's going to be 1 minus the sum of XA to find C. So after you find the value from A to find C, just take 1 minus that value, you find that one. So that is the easier things. Or if you don't want this, you can just say C also. You can also find C in this. It's just 1 minus XB minus XA. It's still going to give as well the same answer like this. So guys, this is how you draw. And then from here, if you can solve now, you can solve the question. But this question was just given to show that stuff. And then from there, you guys know you are able, you will see how you can solve this question. So this is your questions. Try to think and then try to figure out to solve N3, N1, N2, and so on. Okay, guys, let's go. Like I said, I'm going to solve today 10 questions. So there are 10 questions, and those 10, they are very interesting. That is our first question. This is 2 questions. You guys, you will see all there are 10 questions. But let me, before we start, I'm just maybe going to take this question. This question was your test 2, if I'm not mistaken. In this question 2, this was your question like this. And then I'm just the one who wrote this because I want to explain why I put it. This is the question, guys. And then they say we are told that M3 is 50% of the flow rate of M1. and then that 90% of C is M1 exists in N5. The question is said to perform the degree of freedom analysis. So they ask you to find the degree of freedom. Guys, what does we say there? We say degree of freedom is unknown minus known. And how to see the unknown one? From this, the sketch one, we can see we have this N1, we don't have the value, it means it's unknown. This guy X2, we don't have the value, it's also the unknown one. This guy as well here, M3 is the unknown. And then here we don't know B, this one. You can even say C is the unknown one. And then here, guys, carefully, we don't have also M5. So it means how many of them? 1, 2, 3, 4, 5. They are unknown one. We don't know them, which is 5. Now where these 3 come? These 3 I just put, I use it from different pen. So it means if you see this equation, how many components do you have? We have this component A, component B, and component C. Is the same. Like neither you don't have, neither you have. But how many there are? A, B, C. So it's 3. That's why we're gonna say this minus 3. And then if you do this minus 3, you find 2. This like we're gonna find that. Now the degree of freedom, if you don't find 0, it means you can't solve it. Because you have to find what? You have to find 0. Now, how does we find this 0? Now, guys, check. That's why they give us the first information here. They say M3 is 50% of what? Of M1. So from here is another equation. So it becomes 1. And then they say again, and 90% of C, it exists in M1, exists again in M5. So it's become again what? The second equations, but those equations you can call them like their space equation. So it's also 2. Then the remainder 2 and minus 2 is 0. That means this question can be solved. Guys, carefully, if you find some number like 1 here, then you have a problem. It means you can't solve this equation. So the degree of freedom, when it's a reach, you find it 0, and then it's mean you can solve this equation. Let me just take the paper and then let's see how we can solve this question. Okay, the first question we've been asking to find the to perform the degree of freedom. This is the answer already we found is like this, and then you got your full mark. Now the second question is find all the unknown. It means they ask us to find what I already underlined. The question becomes easy, guys. Okay, so now how does we gonna solve this? Very easy. We're gonna solve the same things like I say what I told you. What did I told you in the beginning? I say when you have a question like this, what you have to do, it's first called mass balance, right? Mass balance. Let me write the mass balance. And then this mass balance you can also call the overall mass balance. It means everyone, like all the components. And then what does we say? We say mass balance, it means what? Mass in mass equal to what? To mass out. You see? Now, maybe another question interesting. If we take this guy, we put here mass in minus mass out. How does he call it? It's called accumulation. So accumulation in other way, I just put there. Accumulation, this is accumulation. It means what? It means mass in minus mass out. Okay. But this is not our business. Our business is just no. It means the accumulation is 0. And if this accumulation is 0, you're going to left with mass in is equal to mass out. Okay. Now, what is the mass? Guys, you write what you can see. What is the mass we can see from this equation? We can see the first mass. What is the first mass? Is M1, this guy, is also going to this guy. So this day, it's like you have M2. But this M2, they already give you the value. So you're going to have plus M2 equal. This we have M3. And then this, you can call it M4 plus M4. They are mass flow rates. Why mass flow rates? Because they are dividing by what? By hours. So when you have something kilogram per hour, it means mass flow rate. If you have meter cube per hour, is a volume flow rate. So now plus what? Plus M5. This is our overall material balance, guys. So it means everything we are doing is gonna depend with this question. And then in this question, you can call it like the mother. It means this is the question. It's gonna help you to solve every single thing. Let me just underline them, guys. Very well. Okay. So this is the question. It's gonna help us to do what? To solve everything. Now let's see how we are going to do this. We can substitute the value, so we can substitute the value, right? M1, we don't know M1, we repeat M1. M2 we know is 5,300 equal M3, we don't know M3, we're gonna repeat M3, plus M4 we know is 1,200 plus M5 we don't know. So guys, this is a value and then this is a value, so we can add them. So either you put, it's gonna be M1 this side, you take this guy, this side is gonna be negative M5. You take this guy, you put here also negative 3, and then you're gonna have this guy 1,000. They just put 1,200 minus, because it's going that side, minus 300. So this is gonna be 1 minus 1 5 minus 1 3. They are mass flow rates. That's why we put that things. And then this is just gonna give us, I think, let's just take. We're gonna have minus 4,100. It's gonna be negative, right? Because this is 5,000, this is 100, so this guy is bigger than that one. So now this is the one we can call like equation 1. From what? From this. So guys, if you do that, then you are in the good track. And then the rest one now is become easy. You don't have to worry like, no, I'm gonna do this. No, it's very easy because this is the first stuff you have done. Now the second step, what you have to do is say what? You have to do the mass, the component mass balance. And then guys, we're gonna say what? Component mass balance. So this is a component balance, or you're gonna use now for component mass balance. Component is what? We have A, B, and C. We have A, B, and C. That is the mass component you are doing. If here there was D, or even let's say any stream can have just D, so you're gonna put D. Okay, now how can you do? Is your choice. You start the one you want. Any things you want is something you want. But for me there, I will start with the mass of what? Of B, because I know B it's already given there. So if I do the B, this is B. Now remember which formula I'm gonna follow. I'm gonna start follow this formula. So I put here B, it means B balance. Guys, please understand very well. B balance. I'm only gonna put the mass balance of what? Of B. According to what I said in the beginning. Like you only balance each one. M1, what is the value of B? That is the value of B. So you're gonna have 0.03 M1 like this. Because M1 we don't know. And then we're gonna have plus M2 we know already is what? Is 5,300. What is the component of A? Of B is this one. This is the component of B is what? Is X2 only. And then we leave here, we are coming here. We're gonna say equal. What is M3? M3, we're gonna put M3. Does M3 have B? It doesn't have. So you're gonna have 0 times M3. Don't create your own value. No, if it doesn't have, you put 0, it doesn't have. Plus, here and 4 we have is 1,200 times B. Where is B? Guys, can you see B? That is where B is given. B is given in terms of 0.3 minus X to power 4. We have something like that. So, from here, you can put it if you want. You can multiply this equation. You're just going to have 0.03 M1 plus 5,300 X2. This is 0 is gone. So this also, if you want, guys, you can times. You times that one like 1,000 times 0.03. You're just going to have 3/6 like this. Minus, again, 1,200 X to power 4. So this is another equation 2, guys. So from here, we can also do what? We can do the what? The C balance. C what? C balance. C balance. This is the balance of what? Of A. Sorry guys, for B. This is B. Let me underline this equation. We're gonna need this equation, guys. Yeah. So now, what does we need? We need the balance of what? Of C. What is the balance of C? We come here. What is C? 0.7. So we're going to have 0.97 M1 plus. We come here. Does we have C? We don't have C. We have only A, B. C is not. So it means 0 times that number here, which is M2. Equal. And then we have C here. We don't have C, guys. So we're going to have M3 times also 0. We have C in this equation. Yes, we have C. So, and then that C is going to be what? Plus 1,200 x4. That is x4. We have C in this equation. Yes, we have C. So, you're going to have plus 0.4 times M5. So, let me just put it here so that you guys can see. So, this is just going to have 0.97 M1. And then plus what, guys? This is 0. This is 0. So, you're going to have is equal 1,200 x4 plus 0.4 M5. And then this, we can call it equation what? Equation 3. Okay, guys, let's just do this. Okay. Now, from there, what you guys will do, check. From this, we left with the balance of A. Here we have A. Here we have also A. So you can, if you want, you can also put that equation here. It's very important. You can say A balance. A balance. What is the A balance, guys? Here we don't have A, it's 0. Let me just write. So it means we have what? So that you guys, you can also see here. Like in terms of A, we're going to have 0 times M1. We have A, yes, we have A in stream 2. This is part A. So is what? Is 5,300. 1 minus x2 equal in stream 3. Yes, we have A. So is 1. So we're going to have 1 times M3 plus in M4 we have A. We check in M4 if we have A. Yes, we have A. So we're going to have 1,200 times 0.7. In 5, do we have A? We don't have A. So it's going to be also 0. So we're going to have plus 0 times 1, 5. Because here, guys, you see, we don't have, we only have B and C. So now check here. So we don't need any more this paper. Maybe we're going to need for few information. But anyway, this is 0. We're just going to remember with this 5, 3, 0, 0. 1 minus x2. This is 1, 3. This, if you take the like 1,000 times 0.7, we found only plus 8, 4. So, if you see, guys, this part is also a number, right? If you can put that side, you can even stop here. It's not a problem, guys. So this is equation 4, right? Equation 4. I just want to underline this equation. Now, guys, can you see? We need to solve what? The question to solve the unknown. We have to solve 1, 1, 1, 2, 1, 3. 1, 1, 1, 3. From here, we can see. We need to solve 1, 1, M1, X2, M5, M3, and then we have to solve X4, this. Okay, so from here, so far, if you guys, you have any problem, you are more than welcome. You can test me and then we can discuss. This is how now we will do. Now, does the question is going to stop there? From here, guys, we can't solve this equation. Because check how many unknown. Like in this equation here, this we already derive it to become this. We have 1, 2, 3, 3 unknown. But if you check here, how many again? 1, 2, 3. We have another things and then so on. So we can't solve. That's the reason why does give very good information. What was those very good information? It's this information. They are very important, that one. Because they say M3 is 50% of the flow rate of M1. That they make it easier. What does it mean, guys? If you see something like that in the question, it means what? It means this. I can use the second paper. So it means they say M3 is 50% of M1. So it means M3, the mass flow rate, is 50% is 0.5, right? M1. Guys, we have another equation. That is that two equation when we use, when we say what? When we're saying about the degree of freedom. Well done, guys. So they give us, and then they say M1, and 90% of C. Guys, you see they mention C. Where is C? C is this one. Because they say in the steam what? In the steam one. If they mention C from here or A, we're supposed to deal in that one. But here they mention what? C in the steam one. What is the value of C? Is that one. And then what again? 90%. So what does it mean? It means we're going to have 0.9, this, now, of C. Where is C? Is that one. So we times by 0.97 M what? M1. And then now this is the one give the exist what? Which is 5. And then now what is the 5 in terms of C? You come in 5 in terms of C is that number. So is 0.4 M5. Okay, guys? So if we say 0.9 times 0.97, so we're going to have something like a 0.873 M1 equal to 0.4 M4. So guys, this is another equation. We are happy because since we found out this equation, now we can solve this material balance very easier. So here we can solve everything. Now, let's see now how we can solve. Okay, guys, what I'm going now to do here is what? I'm going to put all the equation we have. So we don't need any more this. So the only things now we need, equation, we need this equation, this equation, this equation, this, and then those two equations. I'm going to put them together so that you can see. Okay, let's see how we can do. I can call this. I can even say this equation 1. I call this one because it's a small one. So M3 equal to 0.5 M1. I said this is equation 1. I even wrote there. We put 2 again. What will be 2? This equation we found here is 0.873 M1 equal to 0.4 M, like this 5. I put this equation, I call it 2. And then what we can do now from here, we can now take this equation, this equation here, this one, can you see all? Yes, is what? I can do just 3 like this. We say it was what? It was M1 minus M5 minus M3, and then this was equal to minus 4100. And then we can call this equation 3. Guys, can you see? Is this equation? I just copy this question, I put. And then which equation we need? I can come here, I put also 5. All the equation we already found, they are already there. So I'm gonna take this equation, this one, this equation is here, this equation. So that equation we say is 0.03 M1, and then we say plus 5200 x2, and then what does we say? We say is equal to 360 here, and then minus 11200 x4. Okay, so and then if we need another equation, we can take another equation. Which equation? We can take this equation. So I can call equation 6 0. Guys, they are very easy. You don't have to worry like they are very long. They are not even long, they are just easy. And make everyone so that all of you guys you can understand, which is 1000 x2. This is this one. I'm sorry, it's x4. And then plus what? Plus 0.4 what? M5. Yes, guys. If you want, you can also take this equation you put here, but you don't have to worry, because we have a lot of equations, so we have more information, we can solve everything. Why, guys? Check, in this equation we have only x2, but x2 it's already repeat somewhere there, this one, so we're gonna solve even from there. Now guys, check how we can solve this equation. That's so beautiful, right? Because we have now everything. The only things now we need is what we have now to solve the equation. Now how can we solve this equation? That is where now the problem starts, huh? Okay, we will do this, guys. Sorry for my camera. Sorry guys, let me just put my camera well. Oh, okay. Okay, so guys, what we will do now from there, we will do what? We have this equation. Can you see? Remember what I told you, like you have to go where there are easier things. You see here, it's only the easiest one. So from here, we can do what? We can solve that equation. How can we solve now that equation? You guys will see now how we solve now that equation. How we can find the value of M1 or the unknown we already put there. because that's even the question. The question is to solve what? Is to solve the unknown one. So, and then we have to solve now the what? We have to solve the unknown. Okay, so from there, what you guys now you will do, in this equation we have m1. Can you see? We have m1 and m5. You see, guys? So we can solve n5 in this equation. We solve n5, guys. Let's solve n5, this equation. So this equation, m5 is just gonna have what? We're gonna divide both sides by 0.4. So we're gonna have 0.873 divided by 0.4, which is m1. So I'm gonna take this number, divide by 0.4. I'm gonna find something like a n5 is 2.1825 m1. Okay, guys, can you see now? This equation, it's become very what? Very easier. Now, how can we do to make it very easier? Can we call also this equation? Where did we stop up with equation? So we stop like this was 4, and then this 1, 2, 3, 4, 5. Yes, this was 5. Can we call this equation 6? Now, guys, check. This is what? M5. We have M5 there. M3, we have M3 there. So this equation can become in terms of what? In terms of M1. So what you can say, you just want to say put, let me just write there, put equation what? Equation 1. You see? This equation. Equation 6, this equation. In what? In 3. So you put those equations here, you're going to solve. Very easy, right? We're going to have M1, so you put M1 is this. M5, what is M5? M5 is this value. It's already minus 21825 M1 minus M3. What is M3? Is 0.5 M1 and equal to minus 4100. Guys, can you see we have only M1, M1, M1. Well done, guys. So then from there we can solve. So this guy's negative and negative is gonna be negative. So we say that 0.5 and then plus 1. So here if you do the division, you just the subtraction, you just gonna let it for 16825 M1 equal to minus 4100. Can you see, guys? Now from here you can solve M1. M1, to solve it, you just divide both sides by this number. So we're gonna have 4100 divided by 1.6825. So 410 divided by that answer. So by doing that, guys, we're gonna find N1, which is very big number. So you're gonna find 2436.8. So if you want, you can round off, and then what will be the unity? Oh, sorry, guys. This, let me just put it the camera. Oh, sorry, Jesus. So this is just gonna find, and then the unit is just gonna be kilogram per watt per hour. Because why? Because the steam we're given, if you see, guys, from here, the steam we're given was, this guy was in kilogram per hour. So this value we're gonna find is kilogram per hour. Yeah, I see now, you guys, you can see. This is how I did. So I can just repeat, maybe you guys you didn't see. From here, what I did, I called this equation 3, equation 1. Here I solve for N5. We are here. And then I found this answer. And then I say put equation 1. What is equation 1? Is this. Equation 6. What is equation 6? What is equation 6? The one we just found, this one. We put it in 3. We put here. We're going to have M1 only. And then we solve M1 to have this. Guys, can you see? Now, if we solve M1, the question become easier. How? We just want to take this value and then we plug here. We find what? We find M3. You see? So M3 in another way is what? We say is 0.5 M1. What is the value of M1? We found already 2436.8. So 0.5 times 2436.8. The answer is what? The answer can write here is 1201 and 80.4. The unit is still kilogram per watt per hour because they are mass flow rate. Can you see, guys? And then we found that So we found M already what? M3. This is what? M3. This is M1. Now, how can we find N5? We come here again. We can find N5 from this equation, right? What is N5? N5 is this equation. M5 is 2.1825 times N1. So I can also write here as well. Let me just write here. So N5 is going to be 2.1825 times N1 is 2436.8, and then if we see that number is gonna give 2.1825 times 2436.8. So we're gonna find something like a 5318 comma, there are too much, just gonna stop there, and then we call kilogram per watt per hour. You see, we found that one. This is our. Now guys, if you check how many things we found already this N5, we have N5, we have N3, we have N1. So what does we can solve now? We can come here. If we put here N1, can you see guys? We put N1 here. If we put N1 here, this is gonna be equation, but that's very long. Check now the following equation, this equation, the last one, 0.97 M1. We're just gonna put the value of M1. What is M1? We know already M1, so we can solve for N4. Make sense, guys? Huh? Okay, now let's see how we can solve this. Let me just take another paper. Okay, so I'm gonna be here. Can you see all? So is 0.97 M1 here, N1. What is M1? M1 already found is 2436.8 equal to 1200x4 plus 0.4. N5. What is N5? N5 is 5 times 5, 3183. So from here we can only now solve for what? For x4, guys, which is very easy, right? It's a straight one. So this guy can come that side, right? So I'm gonna have 0.97 times 2436.8. I'm gonna find 2363.696 and equal this guy. What I'm going to do with this guy, guys, can you see? Is 0.4 times 5318.3. So I'm gonna find something like I repeat this number. If you times this guy, you're gonna find plus 2127.32. So we are solving for x. It means this guy is gonna come this side. We're gonna have 363.696 minus 2127.32 equal to 100x4. So we take that guy minus 2363.696. So we're gonna find what? We're gonna find the positive answer, which is 236.376 equal to 100x4. We are looking for this, so we can divide both sides by that number. So if you do that, this is gonna cancel, it's gonna cancel, so you're gonna have x to the power 4. And then, so if we take now that one, we divide by 112. So we're gonna find 0.19. So we can round off that one to make it 7. So now we have this in terms of percentage is 19.7%. So we have that things like that. This is our x4. So now guys, come here. We have what? We have x4. So we can solve for x2, right? Because the equation is what? The equation, we can all of us see that equation. To see that equation, we all of us see that equation. We're gonna take which equation? We're gonna take, we know like a 0.031 M1, which is this one. This plus 5200 equal, we know that, equal to what, guys? I'm sorry. Yeah, we have this equal to 3, that's, I'm sorry, x2 equal to 36 minus 200x4. So from here, we are solving for x2. This is x2. So here we have 0.03 times m1. We know already the value of m1. M1 was this. This is the value of m1. So it's what? 2436.8 plus 5200 x2, the one we are looking, equal to 360 minus 00 times what? 0.197. This value for x4. So from here now, this is the value for x was meaning. We can solve. This is a number from the 36 minus 1200 times 0.197. We're gonna find here by doing just this. We're gonna find 123.6. So we have to take again this guy times 0.03 times 24. Like gonna have 4, that is 4, 36.8. So we're gonna find something like a 73.014 plus 5200x2. So this guy can go that side. We're gonna have 5200x2 equal to 123.6 minus 7304. So now solving for x2, that's the result we're gonna find there. If you take these two numbers, just gonna have 50.496. You divide now by 5200. So it's a bit a real percentage, which is 9.7 times 10 to minus 3 in terms of fraction. But if you make it in terms of percentage, it's something like 0.97%. This is how you should solve now all the question. Now we have everything. So this is x2, this is x4. Now, this is your own things you will do. If you wanna make it like this stuff you want just to do it a reality. Plug the value of m1 here, plug the value of m2, that number gonna find, and come plug the value. If they don't balance, then it means wrong. But the way we are doing, if you balance, it's gonna give you exactly the same answer. So yeah, this is how you should solve this equation, and I believe you all understand. Now let's go to other questions. Okay guys, so I think now this is where we start, because that question we just solved, the first one was for your test. Now guys, let's see how we can solve these 10 questions I prepared. We're gonna start with the first question. The first question, it says, like I believe all of you can see, the question says 2 methanol water mixture are contained in a separate flask. The first mixture contains 40% of weight of methanol, and the second contains 70% of methanol. If 200 grams of the first mixture is contained with 100 grams of the second, what are the mass and the component of the product? So from here you see they say product. So from here what you can do, the first things do what guys I told you. The things is what you have to draw the picture. This is the question. Let me just put the question. Okay. So they say 2 methanol. So we first gonna draw, I'm gonna put the solution. Okay. So we have to draw the things you see. This is how we can draw. I can't draw well, but you guys have just to understand. So they are talking about methanol. So when they are talking about methanol, that methanol is mixture with what? With water. What is the formula phase of ethanol? Methanol is H, like you guys you know, I believe, is H3OH. So this is a methanol. So, and then another element is water, which is that water. So now let's draw. They say 2 methanol. They are mixed. So it means this is the first one. I can put even the second one there. Even if you want, you can put both them. And then there is the third one, which is a product. So we are there in the product. So what we can do, we just watch what we can see. What they say 2 methanol is mixture is contained. The first is contained, this is a fix, is contained 40%. So this, let's call this the X, and then let's call this Y, we can call also X of water. So this is, I'm gonna X, I can say H3, it's mean for ethanol, and then this I can just put water, you guys you know. So now what does it mean? It means like this, the first one, that first one, it contains the mass flow rate. What is that mass flow rate? Is that one. So we have a mass is 200 gram. So this is M1. And then this M1 is contain 40%. So the X of what? Of ethanol, methanol, I'm sorry guys, say H3, which is what? Which is 0.4. 40 in times is 0.4. So it means the rest. What will be the rest? The rest is water. You see? Water is just gonna be 0.6. That is the X of what? Of water. So now the second one, it contains 70%. So we're gonna have X of the second one, which is say H3OH, is what? Is 0.7. And the H of water is just gonna be what? 100 minus this one. In terms of percentage is 1. So you're gonna have 0.3. And then we're given its mass flow rate, like a 2. And then this mass flow rate is what? We're given like it's 150 gram. This is a mass. Now the question is to ask, find the mass here, which is mass 3. And then after you find the mass 3, you have to find X of say H3. And then you have to find also what? You have to find the X of what? Of water. This is how the things you have given we have to ask. But guys, like I told you, the first things when you are doing those questions, what you have to do is what? You have to do the mass balance. So you're gonna do what? You can also do the degree of freedom if you want, but it's not really a must. The question didn't ask a degree of freedom, but if you want, you can, so that you will see if the question can be applied. But this question, you can. So the things now, guys, what you have to do now is what? We're gonna say mass balance. Remember, we say mass balance is what? Mass balance is mass in equal to mass out. This is guys in, which is gonna call mass 1 plus M2, this guy, and then equal to what? To M3. So guys, this is a bit easier one. We just gonna go straight. So we know M1. What is the value of M1? Is 200. Plus we know that's one, which is already 150. So we're gonna have 150 there. And then this is just M what? M3. So solving M3, this is mean therefore M3 is just gonna be what? We're gonna find something like 350, right? 350. The unit is what? Is gram. So we found already this question by using that. So what now we need? We have to find out is component. So I can just put a little bit there. You guys, you can see everything, right? So now here we're gonna do what? Component balance. Component balance. And then guys, how many component balance here we're gonna have? We're gonna have only 2. It's gonna be for benzene, I mean methanol. I'm sorry guys, not benzene, it's methanol, which is say H30H, and then we're gonna have for water, right? So from here I can start for anyone you want. Can we start for I can start for benzene. So I'm gonna put benzene. So it means I'm doing the mass balance, the component balance of what? Of benzene. I'm gonna follow this equation. M1 I know already. What is benzene? Is 0.4. So I'm gonna have 0.4 times 200 plus. I know here benzene. Yes, I know. I mean the methanol is 0.7. So I'm gonna have 0.7 times the flow rate is 1.5 equal. Here I know, I don't know, because that's even the question that side. So we're gonna have X S CHOH like this. It means methanol. And then we times this flow rate, we know already is 3.5. And then from here we can just take the calculator. We have 0.4 times 200 plus 0.7 times 150. So we're gonna find 185 equal to 3.5 X of CH3 like this. And then we need to solve this. We just divide both sides by 315. So we're gonna have that H, and then so this we're just gonna have 185 divided by 3 and 50 divide by 3.5. You guys, you're gonna find something like 0.58. I'm sorry, 2. There is 2. And then if there is also 8 there. If you want this, you can just round off. Is equal to 0.53. In terms of percentage, is just 53% of what? Of ethanol. But now if you find that to become 53, what will be water? Just take 100 minus that one. Let me just do this. Gonna take 100 minus what? 100 minus that things. So we're gonna have this. So to find D, I can just write here. So we're gonna have for x of water, we're just gonna have 100 minus 53. 100 minus 53. We found 47. So this is 47%. In other way is 0.47. So this is how you guys you should solve this question. It was very fast. So yeah, let's move to another question. Okay guys, let's solve that question. Sorry. The question says a solution composed of 50% of ethanol, 10% of methanol, 40% of water is fed at the rate of 100 kilogram per hour. So from here we can start even draw the diagram we are talking. That is a diagram there. Guys, I'm sorry for the diagram. They say we have that a feed. That feed is what? We have a feed, so which you can call it F, which is what? 100 kilogram per watt per hour. And then they say we have 50% of ethanol. So we have X, I can put this E. It means for ethanol, which is 50% is 0.5. And then we have 10% of methanol. So I can just put XM, which is methanol. It's 0.1. And then the question says 40% of what? 40% of water. So this I can put X, and this is a water we know, which is 0.5. And then now the question continues, says like, it's separated that the product one. So now we say what? The product is always the out one. So we have a product, and then that product, what they say from here, you guys can see it's separated that they produce one stream, and the second stream, the unknown composition. So it means we have another product there. And then this one, we know this mass flow rate we were given. Is mass flow rate is here, guys. Can you see? I can call product. So we have 60 kilogram per watt per hour. And then what they give, they say 80% of ethanol. So I'm gonna have X A, which is 80%, and 80% is 0.8. And then we have X of what? Of methanol, M, which is 15%. If you want to put 15%, in another way, 15% is 0.15. And then we have water, which is X of water. We have what? 5%, which we know like is 0.05. And then we have now everything there. And then now the question say like, if you guys you can see, the second stream is unknown of composition. So it means in this one, we don't know anything. I can call it what? T. Because I'm treasure, you can call anything you want. So we have to find X of ethanol. We have to find X of methanol. We have to find X of what? Of water. So this is how always you guys, you have to think in this question. The question A was what? Question A, sketch the completely the label of flowchart of the process. This is exactly how we answer. So this is our A. And then question B, calculate the composition in percentage of the composition in the unknown stream and the flow rate. So they ask us to find everything. So they ask us to find T, X for ethanol, X of methanol, and X of water. So you guys, so that you can't have any confusion, I'm gonna put the P. On top I put P. It means that is for the product. This is for what I'm looking. I put the T. So that you guys, you can't confuse. I put feed. This is feed. It feeds. So it means when we say XF, it means the percentage of ethanol in the feed, the percentage of ethanol in the product, the percentage of ethanol in that product. By the name of the product, we call it T. You can call anything you want. But the first things what you have to do is what? Like I told you, you will do what? Mass balance. We're going to put mass balance. And what does we say about mass balance? We say mass balance is in equal to what? To out. So what is in? In is F. Equal what is out? We have T plus P. So from here we can solve T. What is T? T is going to be F minus P. So from here we know what is F is 100, P is 60. So here we're just going to have 40 kilogram per watt per hour. So we solve already what? We solve our T, which is the question say the composition, the unknown of what? Mass flow rate. This is our mass flow rate is 40 kilogram per hour. So now, what does we need now? Again, we need to find this X of ethanol and methanol and what? Remember what I told you guys, like when you have some things like this, what you have to do is what? You have to do the mass balance. So you're gonna do the mass balance of each one. So like from here, let's say we choose, we're gonna say component, the balance. Remember, we do the component balance of what? We do the component balance of ethanol, methanol, and water. So they are there. Ethanol, methanol, and water. But here me, I will choose to start with what? I will choose to start with ethanol. I put ethanol. We know already the formula. This is the main formula, this guy. So you're gonna say F. What is F? So you're gonna have 0.5. In the feed, we have 100 equal. T, we know T already is 40. X, we're gonna put X of what? Of ethanol in T plus product, we know product is 60 times, what is the product of ethanol there? Is 0.8. So from here we can solve that guy. So take 0.5 times 100 is 50. So here we have 50. This guy, we take 60 times 0.8 is 48. So you're gonna have 40 XA in T plus 48. So we have to take 48 that side. So we're gonna have 50 minus 48 equal to 40 X ethanol of T. So we divide both sides by what? By 40. So XA for this is gonna give, this is gonna cancel. We take 2 divide by what? By 40. So 2 divided by 40 is 0.05. But the question was to find this in terms of what? Of percentage. I don't know if you guys can see. So 0.5 in percentage, in another way is 5%. So it means in this product, we have 5% of what? Of ethanol. So now the same things now, you will do again the mass balance of what? Of water or methanol. So guys, we don't have a big space. I can just create a space here, right? Good. So what you will do now is what? I'm gonna say the component balance of what? Of methanol. I put the methanol. So we're gonna have what? We have already 1000. What is the steam of ethanol there is 0.1. So we're gonna have 0.1 times 100 equal T. We know already T is 40 times what is the ethanol is the one we are looking for. It's X of T in methanol plus this in that side we know already methanol is 0.0.15 times 60. So we can solve MT. So XMT, if we solve, we will do 0.1 times 100 is 10. This guy, if we take 0.115 times 60, we're gonna have 9. So we're gonna have minus 9, and then we divide by 14. So which is gonna be 1 divided by 14. 1 divided by 40 is 0.025. But the question says we have to find it in terms of what? Of percentage. If you times that number by 100, it's just like what? 2.5%. Now, how to find for water? It's gonna be very easy, right, guys? So for water, I can, if you allow me, I can use water there. So water, we know it's gonna be the sum, right? So you're gonna have water there in T. It's just gonna be like this. We're gonna take 100% like the sum minus the guy we already found, which is 5. We already found again minus 2.5. So we're gonna take that and then plus now 100. So water, we have a percentage of 92.5%. That is how you guys should solve this question. Very easy, I believe you guys now. You see everything is given there. You just go straight and then you solve this question. So, okay guys, that's question 3. Let's see, let's read the question and then we see how we can approach that question. They say any aqueous solution of sodium hydroxide contain 20%. They give the formula of sodium hydroxide by mass it is desired to produce 80% of sodium hydroxide solution by diluting a stream of 20% solution with a stream of pure water. Calculate the ratio liter water needs per kilogram feed solution and K the product solution per kilogram feed solution. This is how you can find your kind of question. This is exactly the question I was writing. The first things, as I told you, is what we draw a picture. Let's draw this. Say a solution, a K solution contain hydroxide solution contain. It contain. So we're gonna put the like always. This is our things we want. And then the first question is what we have been. We have 20% of this, which is 20%. So we're gonna have okay there. We put there. The first things. We have what? We have the mass flow rate. Like we can put M1, but they didn't give, so we're gonna leave first. But you have the 20% of that one, so I'm gonna put like this. Of what? Of sodium hydroxide. I put 1 to show like this percentage come from 1 is what? 20%. 20%, guys, is what? 0.2. And then, guys, when you had some question like this, and then it says what? It produce, guys, can you see? It produce what? 80%. So it produce, this is a product. So from here, you can put what? You can call this M2. You see? And then from here, it produce what? X hydroxide sodium. 2 to show it's from 2 of what? It's 8%. 8% in other words what? 0.08. Now we have that things, guys, and then it's show. Let's just see everything. If we done everything contained by mass, it is desired to produce 8% of solution by diluting the steam of 20% again. Guys, can you see we have again 20%, the one we just wrote here. And then what now the question say? We have to have a dilution solution. So it means we have another entering mass flow rate, which we can call M. We can call this M, like we call it like a M what? M3. So this M3, we don't know as well anything, but here we have what? We have a volume. And that volume is the question we have to find, like we can call volume in what? We need to find for liter, for what? For water. This is the question we have. From the what? From the information. Now remember I told you when you are solving the question carefully when you want to assume. You see, here we can't solve this kind of question without now assuming. So now you're gonna say take a base. You want what? You're gonna take a what? A base. Any number you want, guys. You guys will see gonna find the same question. So you're gonna take a base, and then that base you can take it to become 100 kilogram per watt per hour. You take any base of feed. So it mean what? This is 100 base of 100 kilogram of what? Of feed. Feed. It means this is a feed, M1. So it means we just, you and I, we give the value of M1 to become what? 100 kilogram per watt per hour. This is how we're gonna assume this kind of question. And then now from here, what you have to do is what? We have now to check. If here it's only 0, 2, but the sum of the percentage you must have 1. Where is other? So other is water. So we're gonna have X of water here in steam 1 is 0.8. Because if you add this one, it's gonna give 1. And then here we're gonna have X of water in steam 2. We're just gonna have how much, guys? It's gonna be 92. Yeah, we're gonna have that. 0.92, because if you add 0.8 plus 0.92, you're gonna have 1. So now from here you will do what? You will do mass balance, guys, right? Mass balance. So it means just by doing this, you have already like 95% of your question, because you make everything clear. So now from here we're gonna say what? M1 plus M3 is equal to what? M2. This is your first what? This is your first equation. We have now that. Now the things is what, guys? We have to solve like what you can do now is what? We have this. But here, what is M1? M1 is 100 plus M3. We don't know M3. M2 Same, we don't know. So we have this equation, we have two unknowns. So it means, guys, what as we said, when you have this, you have to do the component balance. So you're gonna put component balance of how many things, either for water or for sodium hydroxide. So I'm gonna put sodium hydroxide. That is for sodium hydroxide. So we're gonna do the mass balance, the component balance of what? Of sodium hydroxide. So this is the formula we start gonna follow, but now we have to multiply with the composition. So we're gonna have 0.2 here in steam 1. What is its flow rate? Is 100. Equal M3, we're gonna put M3. Do we have anything here in M3? So we don't have anything. So we're just gonna have M3 times 0. Plus M2, we don't know M2. Its composition, we're given 0.02 times M2. So from here, we can solve this guy 0. So we're just gonna have what? 0.2 times 100 is 20. So here we're gonna have 20, guys. And then here 0. Here we're gonna have 0.08 M2. So let's solve for M2. We divide 20 by 0.05, we're gonna have 40. So this is 400 kilogram per hour. That is the mass flow rate. So now, if we found this, we have now M what? M2. So we can also solve for what? For M3. Because M3 from this equation is just what? It's just M2 minus 100. So we're gonna have, what is this? What is this M2? M2 is 400 minus 100. So this guy, we're just gonna find 300 kilogram per hour. So now this is, we just solved the what? We solved the mass. Now, is that the question? This wasn't the what? This wasn't the question, because they just help. The question is to find the ratio. You see, guys, from here, what you guys you have to do, let me just take another paper. Yep. So you see everything here we have. So now what we need here, we need some physics. You see, what is the density? Density is mass over volume. So what is volume? Volume, it means is mass times density. So now from here, we can have some clarity. So this, if we say V is M1 divided by the density. Why we put that? Because we know the density of water, we know already like each 1,000. So we know already that the density of water is 1,000. So from here, we can solve something. Now, how can we do? We're gonna say, okay, what is the mass flow rate in V1? We check. You just check it the way we see. The mass we found here, it was in 3, is where there is V, guys. It's gonna be like that. So we're gonna have what? We're gonna have just 1 minute, guys. 2 times 100, that's 20. 20 divided by 0.08. Sorry, guys. So this number is supposed to become, if we divide by 0.28, sorry guys, just make a mistake. This is 2.50 kilogram per hour, because it is 20 divided by 0.8. I'm sorry. And then so here we're gonna have this, sorry guys, we're just gonna have 25 minus 100. So this answer, we're just gonna left you 150. I'm sorry guys, 150 kilogram per hour. Yeah, so it's 150, not 300, is 150. I'm sorry. Now we have M3. This M3's one is 150. Now we have to find from there. What now can we do? We know already, like from here we can find what? We can find the volume. Volume is mass over what? Over that thing. So we're gonna have one. We're gonna check which is the volume. The one with just 150, because it's V3. Why? Because this guy is close to V3. So you're gonna have 150. We divide by 1. And then so this we're gonna find what? we're gonna find 1.5 liter. Yeah, liter, which is like 150 L. So guys, you might ask like, why I did that? You just put the density. If you change the density of water, you want to take it in terms of liter per kilogram per meter cube, you're gonna do that. So we know the density is kilogram per watt per meter cube. So if you want to change this in liter, you just gonna learn like this 1000 in another way, it's just 1 kilogram per liter. This is exactly what we did there. And then if you take this one, is that one, and then you divide, you find that one again. So now we have the mass. That's mass we have. Now what you will do now is what? What you will do now is what? To find now V. That's volume, because they ask us to find the what? To find the ratio. So in terms of find the ratio, it means we need to find another volume. So what you will do now is what? We're gonna take this volume, the one we just found here. Since now is per order of what? So we're gonna take this and then we divide by what? By 1000. Guys, can you see? So we're gonna have 150. We divide again by what? By 100, not 1000. I'm sorry, 1000. And then if you do that, if you do this, you just wanna remember if this is gonna cancel. We're only gonna have 1.5, and then this is gonna be now liter. This is a liter of water per kilogram feed. You see, guy? Kilogram what? Kilogram feed. You guys, you must ask why this 100. This 100 is coming for the mass flow rate one, the first one, the one we're given here. That's why we are subtract. We are dividing that mass. Now from here, now what you will do now is what? This we can call it V1. And then V2 as well. What you can do V2 is what? We divide again by what? By 1000. So what you will do now is what? What was the mass? The one we found here. This mass for, I'm sorry guys, M2. So we found the mass to become was what? From here we can see it was a 250 in M2. So you're gonna have 250 divided by 100. 250 divided by 100. This we just gonna have. This is gonna cancel. We're only gonna have 25. And then this, the unit is now kilogram, the product, so it's kilogram product of solution. This is a solution per kilogram feed solution again. This F is for feed. Now, if you want to find the ratio, it's easier. So we know to find the ratio, it's gonna be now easy how to find the ratio, because you already found like this, the volume, which is 1.5. This is how you guys, you're supposed to solve this question. And I believe you guys, you understand how to solve this question now. 3. Let's move. Okay guys, let's see another question we can solve. This question say it is required to prepare 1,250 kilograms of solution composed 12% of ethanol and it's 8% of water. Two solutions are available. The first contains 5% of ethanol and the second contains 25% of ethanol. How much ethanol solution are mixed to prepare the desired solution? Guys, as always we said, what does we need? We need to draw a diagram. Let's start drawing. They say this is to prepare it. And then they already say how many products. They are say 2 solution. Donc solution they are what? So you have this. This is your box. And then you have now, so it means you have 1 which is going out. And then you might have 2 which is going what? Are going in. So like this guy is going in. And then this guy as well is going in. So now let's now put everything we are given. So you can call this, for instance, this is M1, this is M2, and then this is M3. So now let's see now how the things they say. They said here, it says like this one, we have a 5%, like a 5% of what? Ethanol. So we have X ethanol of steam 1, it's 5%. Guys, can you see 5%? So we put what? 5%. 5% in other way is 0.05. This 5. And then what does it mean? The rest is water. So we're gonna have X of water. We take this 1 minus this. We're just gonna have 95%, and 95% another way is 0.95. So this is for water. And then here the question says again 25%, the second one 25%. So we're gonna have X of A of 3, steam 3, which is 25%. 25 is 0.25, and then the rest one, guys, is what? Is water. This is how you guys you have to start think. The rest one is water, is gonna be this. You take one is 0.75, and then now this guy, it's already even give, that is even the solution. They say that solution contain what? Contain 12. So we're gonna have X of ethanol of steam 2, and then what is the solution? We have 12. 12 is another way, is 0.2, and then the rest is water. So of 2, we're just gonna have it's gonna be 88 in terms of percentage, which is 0.88 of water. Now what you will do now is what? So we in that question, the things we always know, guys, we have to know what? When you have something like this, they give you what? They give you the mass there. You have the like at the mass, they give you one of them. Now you have to ask yourself, what is that mass? That mass you are giving. That mass is what? So this is how you guys, you have to do what? You have to think. So what you will do now is what? What you will do is what? This mass, it was for what? For a solution. So we're gonna say this mass we know already is what? This mass we know already, the value of that mass is gonna be this one, 1250 kilogram. Don't put here no, because they say like is required to prepare 125 kilogram of solution composition of 12. You went where there is 12, you put here. Now guys, what you will do? The same things we usually do. After they do the diagram, we need what? Mass balance. Well done. Now you guys, you know now. Mass what? Mass balance. So now mass balance, you will do what? You're gonna say M1 plus M3. This is just M what? M2, because this guy and this guy, they are going in the same direction. That's why you're gonna have this guy is going to another direction, it's gonna go out. So this you can call equation what? Equation 1. And from here, guys, we know M1, we don't know the value, plus M3, we don't know. M2, we know the value is 1250. Good. So now the second one, we need the component balance. Component balance, we're gonna do for what? Ethanol and water. So here we're gonna start for ethanol. So we know M1, we know 0.05 is ethanol in N1 here, and then we have N1, so we're gonna have N1 there. Plus N2, N3, we are there. Ethanol is 0.25. M3 is what? M3 there. And then here, guys, we're gonna have equal ethanol here. What is ethanol? Is 0.12. 0.12 times 1250, this guy. So from here now, what you can do now is what? We're just gonna take 0.12 times what? Times 1250. We're gonna find 150. If you take this guy is 150, so you're gonna have 0.05 M1 plus 0.25 M3 equal to 150. So this equation faces 2. This is equation 2. So now this equation, guys, this equation and this equation, you can solve the equation, because from here, if you want from here, guys, you can say M1 is what? Is 1250 minus M3. Just take this one, and then this equation you can plug where there is M1 here, and then this can be 0.05 M1, we open the bracket, is 1250 minus M3, yes, plus 0.25 M3 equal to 150. So now from here we're gonna take 0.05 times 1250. So if you times these two guys, we're just gonna have 62.5. If you take this guy, the number is gonna repeat the same, 0.5 M3, and then you're gonna have plus 0.25 M3. equal to 150. So this guy, when it's going this side, is going to be negative. So we're going to subtract that in that number. So we're just going to have this minus that one. We're just going to have 87.5. So now we have to do that as well. Minus 0.05 plus 0.25. So we're going to find 0.2. So we have 0.2 M3. So M3 is just going to be what? 87.5 divided by 0.2. So we divide 87.5, we divide by 0.2, guys. So we're going to find this number. We're going to find 437.5 kilogram. We're going to find that one what? Kilogram. So now we have this. What does the things we need? We have to solve n1. So we're just going to have here 1250 minus. What is n3? Is this one, 437.5. So minus 1235. So we're going to find this flow rate is 12.5. 812.5. So this and this, that's the question they ask. And then you guys, if you want to make sure like the things you are doing is right, you can always check. Come here in this equation. Let's prove this one. This one we know is this one. What is M1? M1, we just found what? We just found 12.5 plus what is this guy? We found this guy 437.5. Let's see the sum, how much it's going to give. If we did the sum, it's give you exactly that one. That's how you prove. And then from there, you guys, you done that question. And let's move in to another one. Okay guys, I think everything well. So we are almost at the end. This is the end of this video today. So I did not make the video like a way they're gonna ask you to change kilogram in newtons or what, because I assume now as a first year or second year student engineers, you have to know how to do those things. So let's just go and then solve this last question. The first step, like always, read the question carefully, and then after read the question, draw the diagram. After do the diagram, mass balance. After mass balance, component balance, and then solve the question. In this question, they say two stage. Now in this question, we have two stage. We have acetic acid. So it's not acetic is not about the stage. It's just part of the question. The stage is what? Is liquid extraction, and then we have also what? We have distillation column. Distillation column. It means we have two stage. So this is the question. They say in a two-stage process, acetic acid A is extracted from water into hexanon H in a liquid extraction. The vessel and the extra subsequently separated by the distillation. Assuming that water is completely isolated in hexanon, a mixture of 18% of acetic and the balanced water is fed to the liquid extraction vessel. Pure hexanol is fed the column extraction of acetic solution, and the water rich stream leaving the vessel 99.5% of water, and the balance is acetic. The hexanon rich extra from the vessel is fed to the distillation column. The composition of distillated is 96 water acetic on the balance of hexanon. The bottom still contain 97.2 hexanon and recover, guys. You see, this is a word, recover 95% of hexanol feed to the liquid extraction the vessel, calculating the percentage of acetic and the process of the liquid. That is the question, guys. Now, what the step is what you have to draw the diagram. So this is how you will draw the diagram of that question. I don't know if you guys can see. This is exactly how you will draw these things. So now when you have some things like this, guys, you have to solve the question. How can we solve? We're gonna say mass balance. So guys, remember this is a liquid. This is a liquid, and then this is distillation column. So now how can we do? We're gonna do the mass balance. Mass balance. You do the mass balance phase of what? You can solve this question separately. You first gonna focus in the liquid, and then later you're gonna focus also on distillation. Mass balance of what? Mass balance of liquid is what? Is mass balance. You're gonna have M1 plus M2, this guy, equal to what? M4 plus M3. We have that things. But now guys, check this. If you want to do the mass balance of distillation, now it's going to be this. So it's going to be what? N4, you see, plus N3 equal now to M5 plus M6. Can you add these two equations? Let's add this question. We add this. We're going to have M1 plus M2 plus M4 plus M3. And then you're going to have M4 plus M3 plus M5 plus M6. We just add. Now, can we see by adding this, guys, can we see like this M3 is also repeating here, so we're going to cancel, because if it's good, it's going to be negative. M4 as well is cancelled. So the overall material balance of liquid and distillation, we're just going to have M1 plus M2 equal to M5 plus M6. So now from here, what you have to do is what? Check in the question. We were not given any base, so that's why I say you can assume, but you have to assume carefully. If you want to assume H1 to become the one you want, it's fine, but you're gonna give you a problem. But they give you another equation instruction from the question, so you can just assume your feed M2 is already what? 1000 kilogram per watt per hour. That is 1000. Why? Because if you assume this, you're gonna solve N6 easy. That's how you make it fast. But it's not a problem even you assume this N1 to become 1000. It's not a problem, guys. You can do that. So now, from here, what we do now? We can solve M6. So what will be M6? M6 is just gonna have 0.95. M1, M2 we know that is 1000, and then we divide that by 0.972. So from here we can solve. So solving that 0.96 times 1000 divide by 0.972, we're gonna find 97.7. The unit is what? The unit is kilogram per watt per hour. We have that. So now, since we have that list, so we are fine, because by having that, now I can just do that because we don't need any more the question now. We need the solution. So now we have N6 here. We can put that N6 here, guys. We have N2. We can have so that you can have just that equation. M1, I take that guy come here. It's going to be minus, guys, N5. And then M6, it's 97.7. I take that guy to put here is also, it's going to give us 1000. Remember, this guy is what? Is 1000. Sorry, guys, this is 7. We have 3 7 here. Yeah. So this is 7, now comma. Yeah. So if we take, and then it's comma 3. Sorry, comma 3. Because this is 1000, you divide by small number, so you must have a big number, sorry. So if we take 977, let me just double check, 0.95 times 1000 divide by 0.972. We're gonna have that here, is exactly. And then that number minus 1000. So we're gonna have N1 minus N5, I'm sorry for that, which is negative 2.6. So we have now this equation. It means what? When we are doing the mass balance, we can just focus on that mass balance thing. We check in N5, we have A and H. A and H. So, but we check here, we have A, yeah. So we can solve this question fast. So how we'll do now? You can do now mass balance, guys. Oh, component balance. Component balance. I'm sorry, guys. We already done mass balance. Component what? Balance. Component balance, you're gonna start for which one? Anything. Like here, we're gonna start with A. We start with A. Or if you want, you can start with anything you want. So which equation I'm focusing? I'm focusing in this equation because this is the overall of everything. So from you guys, I'm gonna leave this question and then you guys, you can solve. Let me just give you some underline because you guys, you have to think, right? So what you guys will do from there, you're just gonna do this. If you take A, it's 0, 180 M1 plus E into, we don't have a 0, we don't have n to right, so we're just gonna say equal. Here in 5, we come 5. What is 5? 5 is here. We have A, yes, we have 0 0.96 M5 plus EA in 6. We have A, yes, we have A, is 0 0.028. But what is M6? We know already M6. You see, guys? So you're going to have 0 0.18 M1 equal to 0 0.96. M5, do we know the value for M5? We don't know. Just chill, guys, you don't have to worry. Plus, this is 0 0.028. M6, we know M6. What is the value of M6? We already found it is 977.3. This value. You see? This value. Is that right? So from here, can I leave? And then you guys, you can solve, or should I solve it for you guys?